What if an airport needed absolutely no land? Seriously, think about it. We're so used to that endless concrete sprawl, not to mention that agonizing hour-long commute out to the middle of nowhere just to catch a quick regional flight. But what if nature had already built a zero-cost runway right outside your downtown office window?
Welcome to this explainer. Today we're looking at something truly fascinating, the incredible transformation of our everyday waterways into highly dynamic, modern aviation hubs. We're talking about Seabases, and how the rise of modern water aviation is totally changing the game for coastal cities, regional transport, and global tourism.
Here's our flight plan for this explainer. First, redefining the modern airport. Second, urban and regional connectivity. Third, the tourism connection. Fourth, navigating shared waterways. And finally, the future of water aviation. Let's get right into it.
Starting with Part 1, Redefining the Modern Airport.
To really understand the power of water aviation, we kind of have to completely dismantle our traditional idea of aviation infrastructure. A sea base, or a water airport, is this brilliant intersection of two entirely different worlds. It's a commercial facility combining aviation and maritime infrastructure. The defining characteristic here, it uses waterways, so bays, lakes, rivers, or harbors, as the actual operational surfaces for takeoff and landing. The water itself acts as a natural runway. This is a massive deal because it completely flips the economics and the physical footprint of the facility. I mean, we're talking zero paving costs and absolutely no bulldozing required.
To put that into perspective, let's look at a direct comparison. Conventional airports demand literal miles of tarmac, and because of those immense land requirements, they're almost always pushed out to the distant outskirts of a city. They're utterly impractical to build near a dense urban center. But sea bases? They utilize shared waterways and floating docks. It's a huge quality of life upgrade. You can literally drop them right into city center locations and bustling waterfront districts. For us passengers, that means bypassing highway traffic entirely. Imagine walking out of a skyscraper and onto a plane 5 minutes later.
Now, a modern commercial sea base isn't just a rickety wooden dock and a windsock. No way. It's a heavily engineered hybrid facility. Aircraft dock at heavy-duty floating pontoons. They fuel up using specialized marine systems, and passengers board from integrated lounges that are actually floating right there on the water. The whole shebang is safely guided in by marine navigation markers. It's essentially a complete airport, just engineered to float.
Moving on to Sections 2 and 3, Urban Connectivity and Tourism.
Let's see how this incredible location flexibility physically manifests in wildly different environments. This really illustrates the dual power of the sea base concept. On one hand, you have a bustling urban waterfront where commuter seaplanes taxi right up to glass terminals, literally sitting in the shadow of major downtown skyscrapers. It just seamlessly integrates into a city's coastal transport system. But then, that exact same fundamental infrastructure adapts flawlessly to a remote, tropical island resort. It acts as a direct lifeline connecting fragmented destinations straight to the passengers, no more relying on slow, cramped ferries.
This adaptability is an absolute game changer for regions dealing with fragmented geography. If you live in or even just visit an area with island chains, deep fjords, coastal archipelagos, or massive lake regions, you know that getting from point A to point B can be a major headache. Usually, you're stuck on long, winding road journeys or those incredibly slow ferries we just mentioned. Water aviation bypasses all of that geographical friction using short-range regional routes. Especially in tourism hotspots, this rapid transit actually turns the journey into a beautiful part of the destination experience itself, rather than just a travel chore.
Which brings us to Section 4, Navigating Shared Waterways. Because, well, it isn't all just smooth sailing and scenic views.
Take a close look at the sheer density of activity in a complex harbor. You've got a control tower and taxiing seaplanes operating squarely in the middle of a hyperactive marine ecosystem. The coordination required here between aviation and maritime authorities is absolutely immense. Why? Because the runway isn't some closed-off, secure tarmac, it's a shared public thoroughfare.
I mean, imagine being a pilot trying to land, but your runway suddenly has a massive passenger ferry crossing right through the middle of it. Seaplanes have to safely share the waterway with colossal cargo vessels, active fishing traffic, private boats, and yes, even the occasional unpredictable paddleboarder. It takes absolute precision and total situational awareness from the cockpit.
And it's not just the traffic. The physical environment itself is constantly throwing curveballs at you. Landing on concrete is static. Landing on water is entirely dynamic. Docking operations have to contend with constantly changing tides that physically alter the height of the terminal.
Pilots and operators are out there managing aggressive wake control from passing ships, highly variable weather conditions on the open water, and strict noise management protocols to keep the surrounding city undisturbed. Literally, the runway changes every single hour of the day. Because of all these crazy dynamic variables, you might be thinking this is some unregulated Wild West of the skies. Actually, scratch that, it is an incredibly strictly governed space. Global operations are overseen by the ICAO, while national bodies step in with highly specific local rules. We're talking about things like the FAA's Seaplane Operations Handbook or Transport Canada's strict guidelines for water aerodromes. They ensure that even with the changing tides and heavy boat traffic, the safety margin remains absolutely rock solid.
Let's head into our final section, the future of water aviation. We've seen how Seabases work today, but how are they paving the way for tomorrow?
Well, cities that are desperately searching for flexible green transportation solutions are starting to look right at their existing waterways as natural transport corridors. By combining conceptual, zero-emission electric seaplanes with solar-powered floating terminals, cities can massively expand their rapid transit networks without paving over a single inch of green space. It's like the perfect marriage of advanced technology and natural infrastructure, a real game-changer for urban air mobility.
Ultimately, commercial seabases represent an amazing intersection of aviation, maritime infrastructure, urban mobility, and economics. They prove that in many parts of the world, the water itself is an untapped transportation network with possibilities that conventional airports just cannot match. So I want to leave you with this thought. Take a look at the river, the lake, or the bay in your own backyard. How will your city transform when its waterways become the new highways in the sky? Think about it. Thanks for joining me on this explainer, and keep learning.